Okay, so this is the video for question 3, the final question of the AQA Arrhenius equation past paper questions. Now, actually, I've pre-filled this because, it's incredibly simple, this first question. You just need to complete the table. So the first column that you need to complete is asking for ln K. So you literally, what's that? Just need to say ln 6.13 times 10 to the minus 5. Oh, what's happened to there? And I've pressed the wrong number as well. Okay, gives you minus 9.70 to 3 significant figures. So I'm not going to do all of those. And then for this one, 1 over t, you're just saying 1 divided by 700, and again giving the answer to 3 significant figures to reflect what you've been given in the table already. Okay, so once you've got those values, you are then asked to plot a graph, and this question is worth 8 marks, and that is to reflect the fact that this time you have not been given any axes. So it's not harder, it's just more time consuming basically. So we've looked at the previous questions of this sort. It says complete the table by calculating, right, plot a graph of ln K against 1 over t. So you're actually told what you need to use. Okay, you might not be though. You need to know that you plot this against this, or in the previous question, what was it, ln 1 over time instead of ln K. Okay, so however, what you do need to recognise here, because you haven't been given a graph that's been started off, is that 1 over t is going to go on your x-axis and ln K is going to go on your y-axis. Now, again, I'm not going to plot it because it's in the mark scheme, but if we just have a look here, so we're plotting y-axis, x-axis, okay? This is not going to, neither of these axes are going to start at 0, okay? So looking at this, we go what, from say like 4 to 10, or minus 4 to minus 10, and here we go maybe from, I don't know, 1.20 times 10 to the minus 3 to 1.40 times 10 to the minus 3, something along those lines. Once I have a look at the grids, then I would sort of finalise that. So let's just have a look at the graph that you are given. Okay, they've actually done their x-axis here, and they've gone from minus 10 up to minus 3. I would have my x-axis up here, and I would go from minus 3 to minus 10 there, but it doesn't really matter. But it is labelled effectively, and also because all of these values are times 10 to the minus 3, to save writing it out every single time, taking up time and space, you just put that in your axes label, and then that takes care of that. So coming back to the question, it specifies, and it's specified in the previous question as well. What have I done with the question? Okay, I've circled it, and I forgot to make a thing of this in the last one. It says use your graph to calculate a value for the activation energy. So what this means is you need to clearly draw a tangent on your graph. You can't just from here say, right, changing that divided by changing that, and that's my gradient. Okay, you need to physically draw it on the graph, otherwise what's the point of the graph? Okay, so let's pretend I've drawn a graph. In fact, shall I just get the graph out? Okay, so there's the graph done, and I've drawn an imaginary gradient, and that tangent, and that's given me a gradient of 28823.5. Okay, so when I did this, that's what I calculated. So remember that our gradient equals that minus, okay? our gradient is equal to that. So if we just want this, then we want to multiply this value by R. Okay, and R, which you're told in the question, but you should know really, is 8.31. And it's 8.31 joules per Kelvin per mole. What is activation energy measured in? Activation energy is measured in kilojoules per mole. So we are going to need to divide by 1,000, okay? It doesn't really matter which stage you do that at, to be honest. The other thing to note is to make sure that we get an accurate answer, I'm going to use this value to 3 significant figures. So I'm going to say 2.88 times 10 to the 4 times 8.31. And that gives me, oh, I haven't written that down, sorry, bear with. 8.31. Okay, that gives me 239,328. I then need to divide that by, oh, not by a third, by 1,000, and that is going to give me 239, and that's it, to 3 significant figures, kilojoules per mole. And that is, oh, sorry, actually, that is my final answer. James, darling, 1 minute. Close the door, close the door. Yeah. I'm just doing a video. Okay, good boy. Where was I? Right, let's do a quick common sense check. Is my value positive? Yes. Does my value fall within the range of 40 to 400 kilojoules per mole? Yes. So, it might be wrong, but if it is, I've got no way of really knowing that, because it probably is right, because it fills both of those criteria. Okay, so that's it. As I mentioned in the previous video, I'm not going to do any for the Edexcel questions because they just follow exactly the same format, but please do get in touch if you require any additional help. All the best.